Hey everyone, so before I get started, I just wanted to take a moment to share another exciting milestone. I was super thrilled to hit the 11,000 subscriber mark recently, and I actually wanted to say something a couple months back when I hit 10,000, but I'm just truly humbled by how many people have subscribed and enjoy hearing my ramblings about retro PC hardware and following along with me as I learn about electronics repair. So from the bottom of my heart, thank you so much to everyone for all of your support and your encouragement. It just really means a lot. And a special thank you to the many people who have donated hardware to the channel as well. I've had a few people reach out to me over the last few months interested in supporting the channel and asked if I had a Patreon page. So after looking into it and giving it some thought, I finally got one set up. For anyone not familiar, Patreon is a site that allows people to make donations to support their favorite content creators. I do all this in my spare time as a hobby, and certainly not expecting to quit my day job anytime soon, but any income that I receive will get invested back into the channel to purchase interesting retro hardware, for better tools and video equipment, and to cover expenses. My patrons will also get some perks like early access to my videos, sneak previews into some of my ongoing projects, and you'll also get your name mentioned at the end of my videos. If you're interested, you'll find a link to my Patreon page and more information in the description below. Anyhow, that's enough of that. Let's get to the main event. Well, I certainly didn't need to buy another broken 3dfx Voodoo 3, but good deal's a good deal, and I always love the challenge. This Voodoo 3 2000 came all the way from a recycler in the UK and cost only 35 Great British pounds, or 35 quid, 35 bob. Not sure how many shillings that is, but more in Canadian dollars, unfortunately. But hey, shipping was cheap, and it's still a great deal for a Voodoo 3 in today's overpriced 3dfx retro market, that's for sure. Especially for one that doesn't look like it was run over by a truck anyway. But as always, it's only a good deal if I can actually fix it. Amazingly, the card looked pretty clean in the eBay listing photos with only two exceptions, a minor bend of one of the heatsink fins, and all three electrolytic capacitors missing from the end of the card. It's actually quite common to see a cap or two loose or missing in these locations. They're really easy to break off if the card isn't stored properly, but all three? That's a first for me. As far as I could tell, there weren't really any other signs of surface mount components missing or obvious signs of trauma, so that was a good thing. Seller really didn't say much about the card aside from a short sentence saying, "shows no signs of life." Not terribly encouraging, but could mean a lot of things, so I figured it was worth a try. So if you're wondering why all three caps are in place on this card I'm holding, and I hate to spoil anything, but I already did some work on this thing, and when it comes to repair videos, I rarely record the intro first, because you really just never know how the repair is going to go. Turned out to be a really stubborn one, and some mistakes were made, so let's rewind a couple of weeks and see how we got here. Yep, looks like the system is angry. I think that's the no video card detected post beep, so not a good sign so far. I don't think that the missing caps should prevent the system from posting, but who knows? Can't say I've ever tried powering up a Voodoo 3 with such a massive lack of capacitance. Nonetheless, it's one very obvious problem that's going to need to be fixed, so we'll start there and do a thorough inspection of the card for damage. The capacitors on the Voodoo 3 are all 10 microfarad, 16 volt rated surface mount parts. I've always used Panasonic FK series caps for these. They're great all around caps and don't cost all that much. About 30 cents each if you buy more than 10. I've got quite a stockpile of these as they're very common type used on many different cards out there. So all three caps on the edge got torn off pretty cleanly. They didn't lift any pads or leave any pins behind from what I can see. Just adding some flux here, and I'm going to remove the old solder using some copper wick. As I mentioned before, I really like MG Chemical's Super Wick. Use it all the time, and it's so much better than the cheap no-name stuff out there. For flux, I'm using Amtech NC559, which is really great stuff that I've used before. So there we go. Looks nice and clean. So there's a few different ways to deal with surface mount capacitors. I like to tin one of the pads ahead of time and then just reflow the solder and slide the capacitor into position using tweezers. This one went into position perfectly, but I rarely get it lined up the first try. Once it's in a good position, I just preload a bit of solder on my iron tip and do the other side. Here's the last one on the edge of the card, and look at that, got it into position on the first try. Alright, so with these three reattached, I'm going to turn my attention to the other two original caps that didn't get ripped off. So as you can see, they do look a little rough, especially on the tops. If I did 3 out of the 5, I may as well do the other 2 here while I've got all my equipment out. I didn't show the method I like to use to remove them here, but be sure to check out my Voodoo 3 repairathon video for more detailed information on Voodoo 3 recapping, and I'll put the link in the description below. But yeah, as you can see, I have to remove the leftover pins from each of the pads before getting them all cleaned up. This is the capacitor near the voltage regulator here, and as you can see, I didn't quite get it seated all the way down, and it is wobbling a little bit. Whenever this happens, just reflow the pad and put a bit of downward pressure on it with some tweezers, and it should be good to go. Here I am putting even more flux on it. It's kind of funny, I've had comments from people saying I use way too much flux, not enough flux, and some people say I shouldn't be using any. But hey, I say whatever works for you, go for it. In my personal experience, I always get better results with generous amounts of flux applied. It is true that it's more to clean up afterward, but with some IPA and a toothbrush, it's really not that difficult to get the residue removed. Trick I like to do with capacitors is to poke the can through some paper towel and brush around it with some IPA, which gets all the harder to reach areas really well. Alright, so 3 missing caps replaced and 2 old caps replaced for good measure. Now before I test the card again, I'm going to put it under the microscope and give it a good inspection to make sure I'm not missing any physical damage on the card. The top side of the card looks surprisingly clean aside from those missing capacitors obviously. Don't see any other missing components, the memory pins look good, and it doesn't look like anyone tried to pry off the heatsink, which is a common way people destroy Voodoo 3s. There are a few resistor networks on the front of the card too, but they all checked out fine. Unlike other 3dfx products, there are no surface mount components at all on the back of the Voodoo 3. And that does help them to survive improper storage over the years, but there are a ton of tiny traces back there with nothing but a thin layer of solder mask protecting them, so I'm definitely going to need to spend some time and inspect them. And sure enough, I found quite a few concerning scratches and dings on the back. Some of them were pretty deep, like this one here, but for every questionable one that I found, I tested continuity with a multimeter just to be sure. I find that looks can be really deceiving with these sometimes. Some of them are pretty superficial, like these scratches here. The exposed copper does make them a bit easier to spot, but it's really the ones that look like impact damage that are a bit more concerning to me. They go pretty deep and they're harder to spot. Thankfully, the trace leading through this nasty looking divot tested okay. By far the worst one is this scratch here. Didn't look too bad until I zoomed right in on it. Trace is almost severed and badly damaged just below that. Looks like it was dislodged and pushed almost right on top of its neighbor. So in order to properly assess it, I'm going to need to scratch away some of the solder mask and get a better look. Thankfully it isn't shorting out against the other, and continuity on both of these traces tested just fine. Still looks pretty bad. I might try to clean it up a bit later, but for now I don't think it's our problem. The label with the serial number also had a pretty good scratch through it, and the only way I could really be sure everything was okay underneath was to remove it. But thankfully, all 3 traces underneath look like they're in good shape. The only other oddity I came across was this bizarre pink-purple toxic waste stain on the PCB near a via. I have no idea what this is, but it looks like it's stained right into the PCB. Doesn't look like it's causing any problems, so I'm just going to ignore it and pretend it's not there. Well, was it enough to get it to post? Sadly not, but not too surprising. All I did was change out the caps. I think the next step is going to be to try the Old Switcharoo, so a technique I've used many times with video cards that refuse to post or just don't display any output. I'm installing an S3 Verge PCI card here that will be the primary display adapter in the system, and once I get into Windows, I can do some more testing. So the system booted without issue with the Verge installed, so let's see if the Voodoo 3 is detected by Windows. And indeed it is. That's always a very encouraging sign and means that there's some life in this card. The fact that it's detected and that drivers are installed and resources assigned is all positive news. I like to use Windows 2000 for testing because it has very robust multi-monitor support and you can use multiple graphics cards simultaneously for display output. Any secondary adapters in the system don't need to have a working vBIOS, and even if the system can't post with them installed, you can often still test them as a secondary card. So let's give this a shot and see what happens. I'm just going to move the monitor cable from the S3 Verge to the Voodoo 3 and let's see if we get some display output. Nice, we do indeed. This card is definitely alive to some degree, and this is smelling more and more like a vBIOS issue to me. Another strong bit of evidence pointing in that direction is found in the Adapter Settings tab. I can see a No ROM Detected message displayed here. I'm not sure if it just can't get valid data from the vBIOS, or if it's not able to detect the EEPROM chip at all. This seems to be consistent even after a reboot, so there's definitely something not right there. So vBIOS bit rot is definitely a thing for cards of this age, and something that I have encountered numerous times now. After 20-something years, enough of those trapped electrons can escape, causing a bit or two to flip, and that's really all that's needed to make the vBIOS unusable. Thankfully, a reflash is often all that's needed to correct this. In my Voodoo 3 repairathon video, 2 out of the 3 broken cards I had suffered from this issue, and I was able to revive them quite easily. Check the links in the description for more information on the Voodoo 3 flashing process and vBIOS bit rot in general. But in this case, I could not get the card to flash for the life of me. No matter what I did, no matter what flash utility version, no matter the BIOS file version, it would always fail trying to detect the EEPROM manufacturer and device ID, and then it can't proceed if it doesn't have that information. So it reports both as 6FH, which is not correct. If I had to guess, that's probably just what it returns if it can't figure it out. Now, the 3dfx flashing utility is very basic, and it has given me issues similar to this in the past, so I spent a ton of time trying every PCI slot for the primary card, disabling video BIOS shadowing, everything I could think of, and I even tried to read it with Uniflash just in case, but this problem really seems to be totally persistent here. It's really starting to look like there's something wrong with the Atmel EEPROM chip itself, or communication between it and the 3dfx vendor chip perhaps. It's not very common, but like any IC, EEPROM chips can fail, and so far everything seems to be pointing in that direction. So I started checking some basic things like making sure 3.3 volt power is supplied to the VCC pin, which it is. I also confirmed that the ground pin is good, and I put the card back under the microscope too, just to make sure that all the chip pins were well attached. And from what I can see, everything looks fine. So since I can't read the chip, can't flash the chip, and can't detect the chip even, I think there's no choice but to get it off the card and into my external programmer to test it out, and if necessary, replace it too. So let's get started. Alright, so let's get this EEPROM chip removed. So first thing I'm going to do is put some Kapton tape all around it. There are quite a few resistors, capacitors, and other passives nearby, and I really don't feel like blowing them all off the card with hot air because it will not be fun trying to fix all that. Next, I'm going to put a generous amount of flux on all of the chip pins to help the solder flow. I am running a bit low on my Amtech, so I picked up some MG Chemicals 8341 to give a try. It doesn't apply smoothly, but it works really well, and the price is pretty good too. I've got my hot air station set to 380 degrees Celsius, or about 715 Fahrenheit for my neighbors to the south. Looking into getting a PCB preheater one of these days, but I've been trying to warm up the cards I work on just a little bit prior to blasting them with heat on just one side. Let me know in the comments what you think. Does preheating help with desoldering jobs like this, and is it worth doing? It's always a bit tricky to film this angle in my garage, but I've got the tweezers under the corner of the chip, and I'm applying almost no pressure at all, just waiting for the solder to melt, and the chip should just let go. And there we go. Lots of smoke as usual from the flux that ran underneath the chip, but looks like it came off cleanly. So the first order of business will be to take a look at this Atmel chip here and see if it's actually bad or not. If it is indeed defective, my external programmer should likely struggle to read the contents. But before I do that, I'm going to need to get this all cleaned up, just using some isopropyl alcohol to get the flux residue off. So this EEPROM is a PLCC32 chip, which was very common for both video cards and motherboards of this era, and came in a variety of capacities. In order to read this in my programmer, I'm going to need to use this pin adapter here. And it works. The TL8662 doesn't seem to have any trouble reading the chip contents. Obviously there's no guarantee what's there isn't corrupted to some degree, but I'll check that later. But from what I can tell, it doesn't seem to be anything wrong with the EEPROM. I was able to read from it, erase it, and write to it without issue. Maybe the programmer just does a better job of it than the card, or could it just be a bug of some kind with a 3dfx flashing tool? Not sure, but it's a bit discouraging. Nonetheless, we've already got it off, so we'll be replacing it anyway, just to be sure. Alright, so before getting an EEPROM back on this card, I'm going to need to get all the pads cleaned up. Chip looked like it came off really cleanly, but my heart totally sank when I took a closer look at the pads. From what I could see, I managed to somehow rip off pieces or mangle at least 3 of them. And of course, I saw this just before going to bed, so I laid there awake for ages thinking of all the best ways to somehow repair this mess I made. Looking at it under the microscope only made me feel worse, but like I said before, looks can sometimes be deceiving when it comes to PCBs, and after giving the pads a reflow, I quickly discovered that this was nothing more than some discoloration. What a huge relief. I went over each of the pads again just to be sure, but they all looked to be okay. I used some copper wick to get the old solder off, and after getting the area cleaned up with some IPA, I'd say it looks perfect and is ready for soldering. I've got a pair of replacement chips here with the exact same part number. I actually bought these last year for the Voodoo 3 repairathon that I did. Card number 3 in that video gave me a really hard time with vBIOS flashing, and I suspected the chip was bad in that case too. In the end, I did get it flashed successfully though. I thought these chips were actually new old stock, but on inspection, they definitely don't look it. I see some discoloration and uneven pins. One of them's got a date code of the 22nd week of 1999, and the other looks like it's from 2002. The metal pins look quite dull, so I'm going to get them cleaned up with some IPA, and then I'm going to lightly polish them up with some 2000 grit sandpaper. Since these don't look like new chips, I'm very curious to see if they are blank or if there's still some data on them. Stupid USB. And what are the odds of that? The chip dated 1999 was from a Voodoo 3 2000. And not only that, it's got the exact same vBIOS version on it as the one I just removed. And interestingly, the calculated checksum of the contents is exactly the same too. But yeah, kind of sad really. A recycler somewhere scrapped a Voodoo 3 for parts, and I can only wonder if it was ever repairable. I did take a look at the other chip dated 2002, and looks like that one was previously on a GeForce 2 MX400. So to get a good BIOS file, the best place to go is a real gem of a site called CL-Raden. Not sure if I pronounced that right. A German site dedicated to preserving 3dfx BIOS files for all cards. Everything from a Voodoo Rush to the unreleased prototypes can be found here, and I'll include a link in the description below. In my case, this is an AGP Voodoo 3 2000 with SDRAM memory, so I'm going to go and grab the latest 2.15.11 release. Now, one problem you'll find is that the BIOS files for the Voodoo 3 2000 are all 32 kilobytes in size, and the EEPROM chip is 64 kilobytes. It was probably done this way for future use if extra space was needed. So the 3dfx flashing utility knows how to handle this size mismatch properly, but an external programmer won't. If I look at this BIOS dump here, you can see that the first half of the chip contains data, followed by all empty space except for just a few bytes at the very bottom. So it's not quite as simple as just filling the first 32 kilobytes of the chip and calling it a day. This pattern of data does exist at the very end of the 32 kilobyte file, so the easiest way to replicate it is just to write the exact same 32 kilobytes again to the second half of the chip, and that required data will be exactly in the right spot. You can do this easily by combining the same binary file twice into a new file using the copy/b command. And as you can see here, the output file is now 64 kilobytes in size. And if I bring it up in the programmer interface, you can see that the required data at the very end of the chip exists. And without further ado, we can get this program to the chip. And as part of the process, the entire chip will get erased, and then all 64 kilobytes of data will get written to it. And I believe it does do a quick read and verification at the end too. I believe I looked into this before and there wasn't enough space for a PLCC32 socket, but I decided to take some measurements one last time just to be sure. And yeah, unfortunately, there's not enough clearance for any of the sockets I could find online. Oh well, looks like we're soldering it directly on again. So the pads are looking good, and I'm just adding some flux here. The chip pins are well spaced, so it should be pretty easy to get it lined up. Watch me drop it perfectly into position here. Not even close. I don't know why I bothered trying. After a bit of nudging though, I'm very happy with how it's placed. Just like with any multi-leg chip, I'm just tacking it down from two opposing corners here. The pins are curled on these chips, so soldering them is a little bit different than something like an SDRAM chip. It took me a bit of time to get the technique down, but I found that wedging the iron into the gap and just adding a bit of solder from the side seemed to work really well. Now that I've got it under the microscope, I can see that I probably went a little bit too far with the sandpaper on the chip legs, but that's okay. And there we go, just inspecting the joints from a bit of an angle to make sure, but everything seems to look good. Not the cleanest looking job I've done, but hey, it works. Let's get this thing installed and try again. Well, that's a bit disappointing, but could it have just been my flashing job? Let's see if the 3dfx flashing utility can detect the EEPROM now. Nope, same exact issue. There's definitely something else going on here, and I'm pretty sure there is nothing at all wrong with the EEPROM chip. I know that the EEPROM is getting 3.3 volt power and that it's grounded correctly, but that's really all I've checked so far. I think it's time to break out the datasheet again and take a closer look at how it actually works. So there's 32 pins in total on the AT49BV512. 3 of them are not connected. We've got one for VCC or power, one for ground, and that leaves us with 27 more. 16 of these are used for addressing, and another 8 are used for the actual I/O from the chip. All of these are obviously important, except for the not connected pins, but there are 3 additional pins that I really want to take a look at first. They are chip enable, output enable, and write enable, or CE, OE, and WE respectively. These 3 pins can have either a quote-unquote low or high voltage applied to them in a number of combinations in order to put the chip into certain operational modes. Modes like reading, programming, enabling or disabling the output, and even product identification mode, which is of particular interest since it doesn't seem to work. The reason I want to start tracing these is because we know the EEPROM can't be read from, and it can't have its hardware manufacturer or device code determined. It's true this could possibly be an issue with one of the I/O pins, but I think first we should figure out if it can even get into the correct operating modes. I was able to trace the CE pin and I didn't find any issues, so I moved on to the OE or output enable pin. I traced it through a couple of vias until it got back to the top side just below the chip. And that trace led right through this curious looking blob here and then further down to another via. And I'm embarrassed to say that I thoroughly inspected the top side of the card and I must have just overlooked this. Kind of looked a bit like a solder mask blob or a bit of dirt, but now that I look at it again, the exposed copper here is definitely a red flag. Let's check continuity between these 2 vias and see what we get. Aha, nothing at all. This trace must be severed. If I touch the exposed copper here, I do get continuity, so let's get zoomed in a bit better and take a look. And wow, at this magnification, it's pretty clear that there's some serious damage here. Looks like something poked it pretty good, maybe the slip of a screwdriver or something like that. I'm going to very gently scrape away some of the solder mask to get a better look, and hopefully I can get enough copper exposed on either side to do a simple solder patch here. But yeah, look at that. Looks like it's totally severed. This via got pretty mangled too, but I'm not worried about it. Just leads to an unpopulated pad, so I'm just going to leave it alone. Next, I'm going to scrape away some of the solder mask from the undamaged bit of trace to the right. I need to get at least some of it exposed for a patch. I'm also going to clean the area thoroughly with some isopropyl alcohol. But yeah, that looks good, and I think it should be quite easy to fix. I'm going to add some flux here, and I've got just a tiny amount of solder on my iron tip. There we go. That should probably do it, but I'm going to add just a little bit more for good measure. Nice. I'd say that looks fixed, but let's test continuity again just to be sure. And bingo, we've got continuity. So before I test the card again, what exactly did I fix here? If the trace was severed, I'd assume that the voltage would always be low on that pin and that it couldn't be put high. But then again, there are quite a few vias on that trace, and I don't have a good view of the full circuit, so I'm not 100% sure. According to the operating modes table, if it was always low, then it would be expected that chip programming and output disable modes would be broken. If it was always high, then reading and product identification should be broken, which is more what we experienced here. I probably should have tested that before getting all excited and repairing it, but reading more into the datasheet, it seems that these output control pins may be used for more than just setting operating modes, so there might be more to it. Let me know in the comments if you have any theories. I'd love to really figure out exactly why it was behaving this way. But at any rate, something was definitely broken, and my theory about it being EEPROM related was at least correct. It makes me feel a little bit better after needlessly replacing the EEPROM chip. But big question now is whether or not the card will start working, so let's get it back in the system and find out. Yes! It works. Awesome. That feeling never gets old when you first see it spring to life, that's for sure. So we have display output, and the vBIOS is clearly being read successfully now. I'm also happy to see that my flashing job was good using the external programmer. We've got the latest 2.15 release on there. Very nice. But we've still got to make sure that the card works under 3D load, so let's launch GLQuake and see what happens. And it works. Fantastic. Looks like this really was the only issue holding this card back. Don't see any artifacting or anything else unusual. So I'm going to give this card a good burn-in session just to make sure, but I'd say this thing is fixed. So there you have it. Hard to believe that this is the 9th 3dfx card I've repaired to date. Really is such an amazing feeling to get something like this working again after who knows how long it's been sitting in a broken pile somewhere. Even though some mistakes were made, and I did do some work on this card that wasn't needed, never feel like it's a waste, and really everything is a great learning experience if you look at it with the right mindset. I'm far from an expert at this, but I always welcome opportunities to learn more and get some more experience. It was the first time I soldered a chip of this type, and digging more into the inner workings of EEPROMs was also a great experience for me. So, what am I going to do with this Voodoo 3 2000 here? I've got a few ideas. I've still got some extra 5 nanosecond memory chips, maybe another enhancement job with some better cooling, and maybe even a mild volt mod to see if I can get this thing going over 200 megahertz. Let me know in the comments what you think. But before I do that, I'm definitely going to see if I can clean up some of the other sketchy looking traces and get some solder mask on the damaged areas. So yeah, hopefully you'll see some more of this card in the future, so stay tuned. Anyway, I really hope you enjoyed this video as much as I enjoyed repairing this card, so please don't forget to like and subscribe if you'd like to see some more content like this. And also please consider supporting me on Patreon. You can find a link to my Patreon page in the description below, along with other information and some useful links. Thanks again.